In this video, we will discuss kinds of quadrilaterals, in which first we will discuss trapezium and kite, then the parallelograms and the special type of parallelograms, rectangles, rhombus, and square. We will also discuss properties of these quadrilaterals. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. In this video, we will understand what are the kinds of quadrilaterals, and the first among them is trapezium. A quadrilateral whose exactly one pair of opposite sides is parallel is called a trapezium. A quadrilateral A, B, C, D is called a trapezium because it's exactly one pair of opposite sides, that is, side AD is parallel side BC, whereas side AB is not parallel to side DC. The parallel sides have been shown by these arrows. A quadrilateral P, Q, R, S is a trapezium because it's exactly one pair of opposite sides, that is, side PS is parallel side QR, whereas the other pair of opposite sides, that is, side PQ, is not parallel to side SR. A quadrilateral LMNO is a trapezium because it's exactly one pair of opposite sides. Side LO is parallel side MN, whereas the other pair of opposite sides, LM, is not parallel to ON. The parallel sides have been shown by the arrow marks. Next kind of quadrilateral is kite. Kite is a type of quadrilateral whose exactly two pairs of adjacent sides are equal. Quadrilateral P, Q, R, S is a kite because it's exactly one pair of adjacent sides, that is, side PS equals side PQ, which are the adjacent sides, and side SR is equal to side QR. So here we observe that exactly two pairs of adjacent sides are equal. Quadrilateral A, P, C, D is a kite because it's exactly one pair of adjacent sides is equal. That is, side AB is adjacent to side AD and AB is equal to AD. Side BC is adjacent to side DC and side BC equals side DC. So therefore, we find that in these two quadrilaterals, exactly two pairs of adjacent sides are equal, whereas the remaining pairs of adjacent sides are not equal. The next kind of quadrilateral is parallelogram. Parallelogram is a quadrilateral whose opposite sides are parallel to each other. Quadrilateral A, B, C, D is a parallelogram because its opposite sides are parallel. Side AD is parallel side BC and side AB is parallel side DC. Quadrilateral P, Q, R, S is a parallelogram because the opposite sides PQ is parallel side SR and side PS is parallel side QR. Quadrilateral L, M, N, O is a parallelogram because its opposite sides LO is parallel side MN and side ML is parallel side NO. Now we will understand a property of a parallelogram. This property states that opposite sides of a parallelogram are equal. So let us prove this property. In parallelogram A, B, C, D, draw a diagonal BD. So the parallelogram is divided into two triangles in triangle ABD and triangle CDB. Angle DBC, which is this, equal angle BDA, because AD is parallel BC and diagonal BD is transversal. So therefore, angle BDC and angle BDA become alternate angles. We name this statement 1. Next, side AB is parallel side DC and diagonal BD is transversal. Therefore, angle BDC equals angle DBA. These are also alternate angles. We name this 2. And side BD equal side DB, which is the common side between the two triangles. We name this 3. So from statements 1, 2 and 3, we can say that triangle APD congruent triangle CDP by ASA test of congruence, which implies side AD equals side BC and side AB equals side DC, because congruent triangles have their corresponding sides equal. So this proves the statement that opposite sides of a parallelogram are equal. Next property of a parallelogram is opposite angles of a parallelogram are equal. Let us prove this property. We have the parallelogram A, B, C, D. Let us draw diagonal BD. We have just seen that because of this diagonal BD, the alternate angles, angle 1 is equal to angle 2 and angle 3 equals angle 4. These are alternate angles. Now in parallelogram ABCD, angle ABC equals angle 3 plus angle 1. Let us name this 1. And angle ADC equals angle 4 plus angle 2. But since angle 3 equals angle 4, we will write angle 3 in place of angle 4. And since angle 2 equals angle 1, we can write angle 1 in place of angle 2. We name this 2. Now, since the right hand side of 1 equals the right hand side of 2, we can write their left hand sides equal. So we write angle ABC equals angle ADC. So therefore we can say that opposite angles of a parallelogram are equal. On the similar lines, we also can prove by drawing diagonal AC that angle DAB equals angle DCB. Next property of a parallelogram is adjacent angles of a parallelogram are supplementary. We will prove this property in a parallelogram PQRS. Side PQ is parallel side SR and PS is the transversal. Therefore, angle P and angle S become interior angles. Interior angles between two parallel lines are supplementary. Therefore, angle P plus angle S equals 180 degrees. Similarly, we also can prove that angle Q and angle R being interior angles, they are also supplementary. So we can write angle Q plus angle R equals 180 degrees. Considering side PS parallel side QR on the same lines, we can prove that angle P and angle Q are supplementary. So we can write angle P plus angle Q equals 180 degrees, and angle S and angle R are supplementary. So we can write angle S plus angle R equals 180 degrees. Next property of parallelogram is diagonals of a parallelogram bisect each other. Let us prove this property. In parallelogram A, B, C, D, let us draw diagonals BD and diagonal AC. Let the point of intersection be E. We have to prove that AE equals EC and BE equals ED. We have already seen because of diagonal BD, this angle 1 equals this angle 2, they being alternate angles, and because of diagonal AC, angle 3 equals angle 4. Now in triangle AED and triangle CEB, angle 4 equals angle 3 and angle 2 equals angle 1, they being alternate angles between two parallel lines. We have already proved that opposite sides of a parallelogram are equal. So therefore, side AD equals side BC. So from these three statements, we can say that triangle AED congruent triangle CEB, the reason being A as a test of congruency. Since these two triangles are congruent, we can say that their corresponding sides are also congruent or equal. So therefore we conclude that AE equals EC and BE equals ED, which is what we have to prove. The diagonals of a parallelogram bisect each other. The measures of two adjacent angles of a parallelogram are in the ratio 3:2. Find the measure of each of the angles of the parallelogram. The two adjacent angles of parallelogram are in the ratio 3:2. So we will assume the adjacent angles of the parallelogram to be 3x and 2x. Since the adjacent angles of a parallelogram are supplementary, we can write 3x plus 2x equals 180 degrees. That will be 5x equals 180, x equals 180 upon 5. That will be 5 ones are 5 threes are 15, 5 6 are 36. So we get x, which is the common multiple of 3x and 2x, is 36. So the adjacent angles of the parallelogram will be 3x, that will be 3 multiplied by 36, that is 108 degrees. So suppose this angle is 108 degrees and 2x equals 2 multiplied by 36, which will be 72 degrees. So say this angle is 72 degrees. We have to find measure of each of the angles of the parallelogram. Since opposite angles of parallelogram are equal, so this angle will be 72 degrees and this angle will be 108 degrees. So this is how we can find each of the angles of this parallelogram. In parallelogram A, B, C, D, the exterior angle DCE is 70 degrees. Draw diagonal BD. Angle A is X. Angle BDC is Y. Angle ABD is 40 degrees. And angle DPC is Z. We have to find the values of X, Y, and Z. Angle BCD and angle DCE are linear pair angles. Therefore, angle BCD plus angle DCE will be 180 degrees. Because linear pair angles are supplementary, that will be angle BCD plus 70 degrees equals 180 degrees. So that gives us angle BCD equals 180 minus 70, which is 110 degrees. So this angle BCD will be 110 degrees. Now in parallelogram A, B, C, D, we know that opposite angles are equal. Therefore, angle X will be equal to angle BCD, which will be 110 degrees. In parallelogram A, B, C, D, because of diagonal BD, angle Y and angle 40 will be alternate angles. Therefore, angle Y will be equal to 40 degrees. We have seen adjacent angles of a parallelogram are supplementary. Therefore, angle ABC plus angle BCD equals 180 degrees. But angle ABC is 40 degrees plus angle Z plus angle BCD, which is 110 degrees, equals 180 degrees. That will be angle Z equals 180 degrees minus 150 degrees. That will be 30 degrees. So the unknown angles are angle X is 110 degrees, angle Y is 40 degrees, and angle Z is 30 degrees. In parallelogram PQRS, PQ is 3y minus 1, QR is 18, RS is 26, and SP is 3x. We have to find the values of x and y. We know that opposite sides of a parallelogram are equal. So therefore, side SP equals side RQ. So that will be 3x equals 18, or x will be 18 upon 3, that will be 6. Also PQ equals SR, so that will be 3y minus 1 equals 26, that will be 3y equals 26 plus 1, 27, so that gives us y equals 27 upon 3, or y equals 9. Therefore, x equals 6 and y equals 9. In the parallelogram HOPE, diagonals HP and diagonal EO are drawn. Suppose they intersect at point A. It is given that AP equals x plus y AE equals 20, HA equals 16 and AO equals y plus 7. We have to find the values of x and y. We have learned that diagonals of a parallelogram bisect each other. Therefore, we write AO equals AE. So that will be y plus 7 equals 20. So that gives us y equals 20 minus 7, which is 13. Also, we have AP equals AH, that will be x plus y equals 16, that will be x plus 13, because y is 13 equals 16, so that gives us x equals 16 minus 13, which is 3. So thus we get x equals 3 and y equals 13. Let us understand about a rhombus. Rhombus is a special type of parallelogram whose all sides are equal. Parallelogram A, B, C, D is a rhombus because its all sides are equal. Parallelogram P, Q, R, S is also a rhombus because its all sides are equal. Let us understand property of a rhombus. The property states that diagonals of a rhombus are perpendicular bisectors of each other. We will prove this property. In rhombus A, B, C, D, diagonals BD and AC bisect each other in point E. Rhombus is basically a parallelogram, and we have already seen that diagonals of a parallelogram bisect each other. Therefore, BE will be equal to ED. Now we only have to show that these diagonals are perpendicular. So, in triangle A, B, E and triangle A, D, E, AB equals AD. Because it's a rhombus, AE equals AE, common side, and BE equals DE because diagonals are bisectors, which implies triangle ABE congruent triangle ADE by SSS test of congruency. Since corresponding angles of congruent triangles are equal, we can write angle AEB equals angle AED. But these two angles are also angles in linear pair, so their sum will be 180 degrees. So we write angle AEB plus angle AED equals 180 degrees, but angle AEB equals angle AED. So in place of AED we can write angle AEB. So we write angle AEB plus angle AEB equals 180 degrees. That will be twice angle AEB equals 180 degrees, or angle AEB equals 180 divided by 2, 90 degrees. Since angle AEB is 90 degrees, it implies that the diagonals AC and BD are perpendicular. Thus, we can say that diagonals of a rhombus are perpendicular bisectors of each other. Rectangle is another special parallelogram whose all angles are equal. Parallelogram PQRS is a rectangle because its all angles are equal. According to angle sum property of quadrilateral, angle P plus angle Q plus angle R plus angle S equals 360 degrees. Since all angles are equal, we can write 4 times angle P equals 360. That gives us angle P equals 360 by 4, 90 degrees. So angle P is 90 degrees, Q, R and S are also 90 degrees. Therefore, parallelogram PQRS is a rectangle. Being basically a parallelogram, rectangle will have its opposite sides equal. So PS will be equal to QR and PQ will be equal to SR, and its diagonals QS and PR will bisect each other at point E. We will understand a property of a rectangle which states that diagonals of a rectangle are equal. We will prove this property. In rectangle A, B, C, D, opposite sides are equal. So AB equals DC and AD equals BC. We have to show that diagonal AC equals diagonal BD. Since each angle of a rectangle is a right angle, therefore angle ABC is a right angle and angle DCB is also a right angle. Now, in triangle ABC and triangle DCB, AB equals DC, opposite sides of a rectangle. Angle ABC equals angle DCB, each 90 degrees, and side BC equals side BC, which is the common side between these two triangles. Therefore, from the three statements, this and this, we can say that triangle ABC is congruent triangle DCB by SAS, test of congruency. Because corresponding sides of congruent triangles are equal, we can say that diagonal AC equals diagonal BD. So this is what we have to prove. Diagonals of a rectangle are equal. Next special parallelogram is a square. Square is a rectangle with all sides equal. Rectangle PLAN is a square because first it is a rectangle and all its sides are of equal length. We will understand a property of a square which states that diagonals of a square are perpendicular bisectors of each other. We can prove this statement on the same lines as we have proved diagonals of a rhombus are perpendicular bisectors of each other. Square being a rectangle, its diagonals PA and LN bisect each other in point E. And because it is basically a rectangle, its diagonals are equal. And since the diagonals bisect each other, the lengths of their bisectors will also be equal. Therefore, PE will be equal to LE will be equal to NE. We can easily prove triangle PLE congruent triangle PNE by SSS, test of congruency. When two triangles are congruent, their corresponding angles are also equal. Therefore, we write angle PEL equals angle PEN. But these angles are linear pair angles, so they will be supplementary. So we write angle PEL plus angle PEN equals 180 degrees. Since angle PEL equals PEN, in place of PEN, we will write PEL. So therefore, we write angle PEL plus angle PEL equals 180 degrees. That will be twice angle PEL. equals 180 degrees. That will be angle PEL equals 180 by 2, that is 90 degrees. So this angle PEL will be 90 degrees. Since diagonals of a square bisect each other and they are at right angles, we can say that diagonals of a square are perpendicular bisectors of each other. We have to identify all the quadrilaterals that have four sides of equal length. Quadrilaterals with four sides of equal length are: one is rhombus and the other is square. Quadrilateral with four right angles will be a rectangle and a square. We have to explain how a square is a quadrilateral. A square is a quadrilateral because it has four sides. Square is a parallelogram because its opposite sides are parallel. Square is a rhombus because it's a parallelogram with all sides equal. A square is a rectangle because it is a parallelogram with opposite sides equal. We have to name the quadrilaterals whose diagonals bisect each other. Quadrilaterals whose diagonals bisect each other are parallelogram, rectangle, rhombus, and square. Quadrilaterals whose diagonals are perpendicular bisectors of each other are rhombus and square. Quadrilaterals whose diagonals are equal are rectangle and square. Friends, if you like this video, please click the like button. Share this video with your friends and classmates. Do subscribe this channel to get more videos of this type. See you in the next video. Until then, keep watching Number Collage. Thank you.